But for today's do now, there's just 2 questions before you guys have some time to work. So the first one says, combine the 2 half reactions and write the overall balanced redox reaction. And then number 2, in this equation, what is being oxidized and what is being reduced? And I said assign or give the oxidation numbers for each. So for number 1, for this one, I already actually gave you the balanced half reactions. So in this, you have the reduction half reaction, because notice how the reactants are gaining electrons. And then here we have the oxidation half reaction, because the reactants are losing the electrons. So for this, you already have the balanced half reactions. And then what you have to do is you have to figure out what do you have to do to these before you can add them up. So they already have 3 electrons in the reduction half reaction and 4 electrons in the oxidation half reaction. Remember, when you add them up, you should not see electrons in the overall reaction. So you have to figure out what to do before you can add them up to make sure the electrons cancel. So on Friday, if you remember, we looked at just balancing half reactions. We didn't add them together. Now today, we already have the balanced half reactions. We just need to add them together. So if we take a look here, we have 3 electrons and 4 electrons. And I just put in a line underneath here because we're going to end up adding these together. So if you take a look at this, I want you to think about what number you can make the electrons equal so that when we add the 2 together, they cancel out. Well, think about the least common multiple, is that the mathematic term, of 3 and 4. The least common multiple of that is 12. So I want to make this top reaction, I want to make this equal 12. And for the oxidation half reaction, I want the electrons to equal 12. And so think about what you need to multiply each one of those by. If I want this reduction half reaction to be 12 electrons, I need to multiply everything by 4. 4 times 4 is 16. 3 times 4 is 12. 4 NO. 8 H2O. So I multiplied the top reaction. I'll just make a note over here. I multiplied by 4. Because I wanted the electrons to equal 12. And then for the bottom, for the oxidation half reaction, again, I want this to equal 12. The goal of making the electrons equal is that when I add the 2 together, when I add these 2 together, the electrons should cancel. You should never see electrons in an overall reaction. You can see them in half reactions, but you should never see it in an overall reaction. So if I want this to equal 12, I need to multiply everything by 3. So I'll make a note over here. Multiplied by 3. So that will make this 15. 3 times 2 is 6. 12. And 12. So now we have our half reactions multiplied by something to make our electrons equal. Now, whether you want to add them together and then cancel, or you want to cancel first, whichever way you do it is up to you. I'm going to look at canceling first so I don't have to rewrite it twice. So when I add these together, here are arrows. They're close to being as lined up as possible. Anything that is the exact same on the left and on the right of the arrows, we can cancel. Remember, your electrons should always cancel. And then sometimes you have other things that cancel as well. So if you take a look at this, I want you to look and see what is the exact same. And maybe it's just partial of something. Remember, you can cancel just partial of something. So I know for sure that the electrons cancel. 12 electrons on the left, 12 electrons on the right. You guys see other things that cancel. So NO3, there's no NO3 over here. H plus, well, there's H plus over here. Now we have 16 on the left and 12 on the right. So not all 16 are going to cancel, but 12 of them will. So if 12H plus cancel, 16 minus 12 leaves me with 4H plus. Then keep looking. I see 15 waters on the left and 8 waters on the right. So again, not all 15 waters will cancel, but 8 of them will. There's 8 waters that will cancel. 15 minus 8 is 7. So if we take a look at this now and I rewrite it, and sometimes when I rewrite a reaction, I realize that I missed something. I missed canceling something. And then I just go back and cancel it and then rewrite it. So everything on the left of the arrow, 4NO3 minus plus 4H plus 7H2O plus 3AS2O3 yields. So there are my reactants. Then we look at our products. So 4NO plus 6H3ASO4. So here is our answer to number 1. Here's our overall reaction. Now it doesn't say anything about it being acidic or basic, so we're assuming they gave us the 2 half reactions. All we needed to do was make the electrons equal and add them together. So again, our overall reaction, our answer for number 1 is what is written in blue here. 4NO3 minus plus 4H plus 7H2O plus 3AS2O3 yields 4NO plus 6H3ASO4. And then number 2, in the reaction below, what is being oxidized and what is being reduced? We give the oxidation numbers for each. So you have to be able to assign oxidation numbers. To do anything else, you have to assign oxidation numbers. You have to know what's oxidized and what's reduced. So in this reaction, we have all of these substances. So let's start by assigning oxidation numbers. Remember the front page of your notes. So the front page of the part 1 notes, all right, looks like this. These are your rules for assigning oxidation numbers. So as you go through and you're assigning oxidation numbers, use those rules. Remember, oxygen is almost always -2. Almost always -2. So I'm going to start with oxygen in both of these. Oxygen is going to be -2 in both MnO4- and C2O4 2-. Oxygen will not be -2 if it's bonded to fluorine, because fluorine is more electronegative. And oxygen will not be -2 if it's a peroxide. You hardly ever see peroxides. You'll know it's a peroxide if they give you the name and they tell you, like hydrogen peroxide. Peroxide is a polyatomic ion. It's O2 2-, so each oxygen carries a -1 oxidation number. But typically, oxygen is -2. So each oxygen in permanganate, MnO4- is -2. So total, all of these O's are -8. Now notice that it's MnO4-. So what that means is all of the oxidation numbers have to add up to equal -1. So now you need to ask yourself, what do all of the manganese atoms need to be to make everything equal -1? So what do you have to add to -8 to get to -1? Well, all of the manganese atoms need to be +7. There's only one manganese, so that means that Mn is +7. So Mn is +7, O is -2. Total, all of the oxidation numbers add up to equal -1. 7 minus 8 is -1. Then we move on to the oxalate ion. Oxalate is C2O4 2-. So each oxygen is -2, but there are 4 of them. So all of the oxygens total are -8. Now because of this -2 charge on the polyatomic ion, all of the oxidation numbers have to add up to equal -2. So now, I want you to think, what do all of the carbons have to equal to make this entire thing -2? So what do you have to add? Exactly, +6. If you do +6, all of the carbons are +6, all of the oxygens are -8. 6 minus 8 is -2. So all of the carbons are +6, but you have 2 carbons. So that means that each carbon is +3. So for the oxidation numbers on the bottom, we're assigning for individual atoms. We have +7 minus 2, +3 minus 2. Now we go on to the products. We have Mn2+. This is a monatomic ion. Monatomic, 1 atom. And so its oxidation number is the same as the charge. So Mn on the product side is +2. And then let's look at carbon dioxide. Each O is -2. So total, all of the oxygens are -4. There's no charge up here. So all of the oxidation numbers have to add up to equal 0. So that means that all of the carbons must be +4. There's only one of them, so carbon is +4. So now, down here along the bottom, we have all of our oxidation numbers. Now we can answer the question, what is being oxidized and what is being reduced? This is a common multiple choice question, like a part A of a free, or not multiple choice, free response. It's like a part A of a free response. They give you a balanced equation, and before you have to start doing all of this math, they say, you know, what's being oxidized, what's being reduced, justify your answer with oxidation numbers. So if we take a look at this, we see that Mn is going from +7 to +2. Manganese, its oxidation number is decreasing. It is reducing. So over here, I'll say Mn is being reduced from +7 to +2. So here's one of our answers. And then we're looking at oxidation. So remember, in terms of oxidation numbers, you have one substance whose oxidation number is going down, you have one substance whose oxidation number is going up. We look at this, we see oxygens doesn't actually change. So oxygen is not going through oxidation or reduction, and that's okay. Not every substance has to undergo oxidation or reduction. But we see that carbon is going from +3 to +4. So carbon's oxidation number is going up. It's being oxidized. So we'll say C is being oxidized from +3 to +4. Remember, with oxidation, reduction, reactions, I'll write it over here, whether you remember it as Leo-Gur or oil rig, they mean the same thing. Losing electrons is oxidation. Electrons are negative, so I'm just putting negatives here. Losing electrons. So when you go from reactants to products and something loses electrons, it becomes more positive. That's oxidation. Gaining electrons. So when you're going from reactants to products and the oxidation number becomes more negative, right? It decreases. That substance is gaining electrons, and that's reduction. So our answer for number 2 is what I wrote over here in blue. Mn is being reduced from +7 to +2. Carbon is being oxidized from +3 to +4. In mastering, make sure you're reading the question carefully, because some of them say which element is oxidized or reduced. Element means, right, Mn or C or O or N. That's an element. If it says write the entire substance, then you'd be looking at MnO4- or C2O42-. So just read the question carefully as well. So we only have 3 days this week because spring break will be Thursday, Friday, and then Monday and Tuesday of next week. So since we only have a few days, I just wanted to show you what we'll be doing for those 3 days. You guys already know what is happening today because I shared that with you guys last week. So for this week, I just, again, took a screenshot of the lesson plans like usual. Today is a work day, so remember that the Redox mastering is due tonight. So it's due tonight at 11:59. You have these 2 periods to work through mastering, ask questions if you have them. If you want to FaceTime with someone else or Google Meet with someone else, you can work with other people on it. From what I saw on Friday, a lot of people were close to being finished with it. And then the other thing for today is if you get done with mastering, you can then watch tonight's video for tomorrow. So tonight's video is the first video in the second part of Unit 10, which is electrochemistry and voltaic cells. So now we're going to take oxidation reduction reactions and we're going to actually apply it to real world scenarios with electrochemistry. So talking about batteries and using reactions to be able to power different substances or different processes. And then tomorrow and Wednesday, we'll be doing some review of the videos that we watched, some examples, and then there'll be a mastering assignment for the second half of Unit 10, but that's not due for another 2 weeks or so. So I didn't even put the due date for that yet up on the screen. But Part 1 mastering is due tonight at 11:59. 27 points possible, but I take it out of 25. So your score on mastering, if it says you have a 95.2%, that is 95% of 27. I will be taking it out of 25. So if you have 100% on mastering, you have a 27 out of 27, which means in Power School, you will see it as a 27 out of 25. So like I said last week, today's a work day. I put the bell schedule up. I know that you guys know it by now, but just in case. So work on mastering. Remember, if you need more practice with balancing, pages 10 through 15 in the notes are really just practice, but page 13 is where I went through and worked through each of these questions. And so there are QR codes. If you want to just see the cool board that I have in my basement, just scan one of those and you can see the board that I was working through the problems on. And then once you're done with mastering, you'll watch video 10.5. The notes are added to the classroom assignment. So I have the PDF and the Google Doc version. If you print the notes out, I would recommend printing the PDF. Sometimes when you print the Google Doc, it gets a little weird. I put the Google Doc there so that if you want to just type your notes, you can. Most people will probably choose to print them. If it's really up to you. So the doc is there in case you want to just type your notes, but if you want to print them out, use the PDF, or you can take notes by hand, right? Either way.